Hey guys, welcome back. So we're going to continue to move on to lesson 5.3. So let me present my screen and we'll get started. We're going to be talking about proving triangles congruent. There's a bunch of different congruency theorems. The first that we're going to discuss is known as side angle side, SAS, and it's actually the first theorem in the lesson. All right, so Theorem 5.5, side angle side SAS congruency theorem, which says if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the triangles are congruent. All right, so again, it's talking about two sides. Ignore that scratch. Two sides and the included angle, that part's important, of one triangle. So here we have a side. Here we have an angle, which is labeled with an A as well, and another side. Okay, the two sides that have the tick marks, the two sides that I traced, they are the two sides that form that angle, which is why that angle is known as the included angle. Over here, we have a side marked with a tick mark. We have an angle marked with an arc and another side. So since this side is congruent to this angle is congruent to this angle, and this side is congruent to this side, we can say that triangle, now I have to erase all my scribbles so I can name them correctly. I could say the triangle BAC is congruent to triangle and name the next triangle the same way. So BAC EDF by side angle side. Okay. Now they named the triangle differently. They said triangle ABC is congruent to DEF. So just like we were naming polygons congruent based on corresponding parts in the last lesson, same thing here. The way I named it is perfectly fine, but based on how you named the first triangle, you have to name the second triangle so that the corresponding parts match up. Okay. All right. So that is side angle side. Now, once you know that the two triangles are congruent by side angle side, that means everything about the two triangles are then congruent. We're going to talk about that moving on. All right, but let's just practice and get comfortable with side angle side. So we have some extra practice. We have some proofs, okay? And in these proofs, we're going to be using side angle side. All right, so let me set up statements and reasons. Try to write small so I can fit it all. Statements, reasons. All right, the first statement is, of course, the given. You're given that BD is perpendicular to AC, and you're also given that AD is congruent to CD. So we need to make sure that that's all marked and then see what other information we can conclude based on that information. Okay, so you're given that BD is perpendicular to AC, which I see the right angle, so that's good. And then you're given that AD, one tick mark, is congruent to DC, one tick mark, which is good as well. All right, so in order to use, and I didn't mention this above, in order to use SAS, we're looking for two sides marked and stated congruent and one angle. I'm going to put stars next to each congruency statement. So I'm looking for 3 stars, okay? So far, I have a pair of sides, right? Side congruent to side. So I have one of my stars. AD is congruent to CD is a side congruent to a side. But I need 3 stars in order to use SAS. All right, so from there, what else do you know? Let's look at the diagram. What other things can you conclude? Remember, if you were to slide the 2 triangles apart, what side do they both share in common? BD. BD is congruent to itself. So my second statement is going to be a reflexive statement that BD is congruent to BD, and that's reflexive. All right, and that is my second star. All right, now I have a side, right? AD congruent to AC, and I have another side, BD is congruent to BD. I need an angle. And it looks like my included angle would be this angle right here, okay, the 90-degree angle. So we need to talk about that perpendicular piece next, all right? So we did talk about the perpendicular theorems a chapter or two ago. Now we can conclude that angle BDC is congruent to angle BDA. Why are we allowed to conclude that this angle here is congruent to this angle here? It's a perpendicular lines theorem. We know that when perpendicular lines are formed, that gives us congruent adjacent angles, right? If we have perpendicular lines, we're going to have two 90-degree angles that are right next door to each other. They are congruent adjacent angles. So that is my third star. Once I have my 3 stars, remember a side, and an included angle, I can then come up with my final conclusion that triangle ABD is congruent to CBD, and it was named correctly in the correct order, so I can copy that down. ABD is congruent to triangle CBD because of side, angle, side. Okay, let's try another one. All right, set up my statements and reasons. We're given 2 pieces of congruency information to start, and it looks like it's already marked on the diagram. So I'm given that JN is congruent to MN, and that NK is congruent to NL. It's given. So, I went too high. I think the J is up here. So this side here, J, is it JN? Yes, JN, this piece here, is congruent to MN. This must be an M up here, MN. And then side NK, I'm just double checking as I'm looking at the diagram, 2 tick marks is congruent to this side here. Now there's lots of triangles to look at, which is part of the problem that this one is a little confusing, but the 2 triangles you're supposed to be focusing on based on the fact that you're told to prove that triangle, I'm trying to color it in a little bit. This yellow triangle is congruent to this yellow triangle. So if you wanted to draw them separated, but still marking everything that you know, you could, okay? Or just try to have your eyes focus on the yellow triangles. All right, so remember, I need 3 congruency statements. I need 2 sides, which I'm already given. I have a side congruent to a side congruent to a side. So in order to use SAS, I need to know about an included angle. Well, the included angle would be this angle here, this angle here. What do you know about those 2 angles? They're vertical angles, so they're congruent. So you can say that angle JNK is congruent to angle MNL because vertical angles congruent. And then you have your 3 stars. Once you have your 3 stars, you should hopefully be able to say that the triangles are congruent. And they probably named them correctly, but we'll just double check. JNK, so JNK is congruent to MNL. So JNK is congruent to MNL by side and side. Okay. All right, let me see what else we have. All right, I think that's actually all I'm going to do from this lesson. Yep, that's all. I just wanted to show you those 2 proofs and how to use side, angle, side. Let me My mouse. Stop sharing. Okay, so that is all that I'm going to show you from the side angle side lesson, these two theorems. I will see you back here for the next lesson. Bye.